Hi students, this is WebAssign number 7, question number 1. And in this problem, we will be using the definition of molarity that you learned during Integrated Science 2. That is, molarity is equal to the moles of the solute divided by the volume of the solution. That is the entire solution, not just the solvent, measured in liters. That's a very common way of measuring concentration in chemistry. So for this first problem, they're asking us to calculate the concentration of the ions present when each of these different solutes is dissolved in a certain amount of water. But notice that they're giving us the volume of the entire solution, not the amount of water that they're putting it in. They're also asking us to find the concentration of the ions, so we'll have to take into account that each of these solutes is a strong electrolyte. That is, it breaks apart into ions when we place it into the water or into the solvent. In the first problem, we're calculating the molarity of calcium nitrate. And so we need the moles of calcium nitrate, that's given, 0.350 moles of calcium nitrate. And we need to divide that by the volume of the solution. But the volume of the solution has to be in liters, and they're giving it to us in milliliters. So we need to make that conversion between milliliters and liters. So we need to divide that by 1,000. 100 divided by 1,000 is 0.1. So we have 0.1 liters of solution. Dividing 0.35 by 0.1, we get 3.5 molar. Should have 3 significant figures. That's the concentration of the calcium nitrate. That is the solute in this particular problem. But they're asking us to find the concentration of the calcium ions and the nitrate ions, not the concentration of the full solute calcium nitrate. So we have to take into account that when calcium nitrate gets into solution, it breaks apart into one calcium ion and 2 nitrate ions. So if the concentration of calcium nitrate is 3.5 molar at the beginning, after it dissolves, there won't be any left. That's what it means for it to be a strong electrolyte. All of the calcium nitrate will break apart into pieces, and none of it will be left intact as calcium nitrate pieces. The original concentration of calcium and nitrate in the solvent was 0. No calcium in water. There's no nitrate in water. But after the calcium nitrate dissolves, because there's a 1:1 ratio between calcium nitrate and calcium, there will be a 3.5 molar concentration of calcium. And because there's a 1:2 concentration between calcium nitrate and nitrate, there will be twice that for the concentration of nitrate. There will be a 7 molar concentration of nitrate. Every time calcium nitrate breaks apart, it produces 2 particles of nitrate. So the concentration of nitrate will be twice that of the concentration of calcium, where only 1 particle is produced. So this value is 3.5 molar, and this value is 7 molar. For part B, we have a very similar problem. we're told the moles of sodium sulfate. So if we want to calculate the molarity of sodium sulfate, we need to take that value for the moles of sodium sulfate and divide it by the volume of the solution. Here they're giving us the volume of the solution, and it's already in liters. 1.25 liters of solution. So 3.5 divided by 1.25 is equal to 2.8. 2.8 molar is our concentration of sodium sulfate. But as before, they're asking for the concentration of the sodium ions and the sulfate ions. So we have to consider how sodium sulfate breaks apart. Sodium sulfate breaks apart to produce 2 sodium ions and 1 sulfate ion. So if the original concentration of sodium sulfate is equal to 2.8 molar, after it breaks apart there won't be any left because it's a strong electrolyte and all of it breaks apart. And originally water doesn't contain any sodium or sulfate ions, but after the sodium sulfate breaks apart, since the ratio is 1 to 2, for sodium sulfate to sodium, then I have to double that concentration to find the concentration of the sodium. So that will be 5.6 molar. And since the concentration of sodium sulfate to sulfate is 1 to 1, then the concentration will match the original concentration of sodium sulfate. So that will also be 2.8. So for sodium, 5.6. For sulfate, 2.8. Problem C has the add-in component that we have to find the moles. Note that they're giving us the grams of ammonium chloride, not the moles of ammonium chloride as they had given for the solute in the previous problems. So I have to calculate the moles of ammonium chloride before I can calculate the concentration. So I have 5 grams of ammonium chloride, and I have to divide by its molar mass in order to determine the moles of ammonium chloride. So in order to divide by the molar mass, I have to add up the pieces. So 14.01 for nitrogen, and I'm going to add that to 4 hydrogens. So each hydrogen is 1.01, but there are 4 of them. So 4.04 for all 4 of those hydrogens, and 35.45 for the chlorine. So that adds up to 53.50. So I'm going to divide this by 53.50 because that's how many grams of ammonium chloride there are in 1 mole of ammonium chloride. So 5 divided by 53.5 is equal to 0.0935. 0.0935 moles of ammonium chloride. So if I want to find the molarity of ammonium chloride, I have to take that number of moles and divide by the volume. The volume in this case was 200 milliliters, which I of course have to change to liters. So dividing that by 1,000, I get 0.2 liters. So 0.0935 divided by 0.2 liters is equal to 0.467. 0.467 molar. That's the concentration of ammonium chloride. But, as in the other problems, they're actually asking me for the concentration of the ions. So I have to consider how ammonium chloride breaks apart when I put it into water. And it breaks apart into one ammonium ion and one chloride ion. Here the ratio is 1 to 1 to 1. So when 0.467 molar ammonium chloride is placed into solution, since it's a strong electrolyte, all of it will break apart. And originally that water solution didn't contain any ammonium or any chloride. But since it's a 1-to-1 ratio between ammonium chloride and ammonium, the amount of ammonium is 0.467 molar. And since it's a 1-to-1 ratio between ammonium chloride and chloride, the amount of chloride, or the concentration of chloride, is 0.467. So these are the same, right? Neither one is doubled as in the previous two problems. 0.467, 0.467. And the last problem is similar to this. I have 1 gram of potassium phosphate in 100 milliliters of solution. 1 gram of potassium phosphate in 100 milliliters of solution. So the first thing I need to do is find the moles of potassium phosphate. So in order to find the moles of potassium phosphate, I have to divide by the molar mass of potassium phosphate. So I have to add in 3 potassiums. Potassium phosphate has 3 potassiums. So 3 times 39.10 plus 1 phosphorus. 1 phosphorus is 30.97. And I'm going to add that to 4 oxygens, plus 4 times 16. So that molar mass is 212.27. So that's what I'm going to divide by here. 212.27 grams of potassium phosphate in 1 mole of potassium phosphate. And we had 1 gram, so 1 divided by 212.27 is equal to 0.00471. 0.00471 moles of K3PO4. To find the molarity, I have to take those moles, 0.00471, and divide by the volume of the solution. The volume of the solution in this case, I believe, was 100 mLs. 100 mLs. But I need to change that to liters, so I'll divide that by 1,000, so 0.1 liters. So dividing 0.00471 by 0.1, we get 0.0471. And that's the molarity of K3PO4. But as in the other problems, they're not asking me for the molarity of the solute as a whole. They're asking me for the concentration of the ions. So I have to take into account how K3PO4 breaks apart as a strong electrolyte when I put it into water. And it's going to break apart into 3 potassium ions, but just 1 phosphate ion. Oops, that's a -3. So if initially the concentration of K3PO4 is 0.0471, then after it all breaks apart, its concentration is going to be 0 because it's a strong electrolyte, all of it will break apart. And if initially the water didn't contain any potassium or phosphate, after it breaks apart, the potassium phosphate breaks apart, it will have a 1 to 3 ratio between potassium phosphate and potassium. So I'll have to triple this value. That's equal to 0.141. And there's a 1:1 ratio between potassium phosphate and phosphate, so that concentration will be 0.0471 molar. So 0.141 for potassium and 0.0471 for phosphate. That's question 1 in WebAssign 7. There'll be a separate video for the other questions. Thank you.